Very good question. Okay, so watch this. We're seeing Physarum polycephalum, the slime mold. This is one of its little veins pumping cellular contents around, but look what just happened. It stops and then reverses flow. Why does it do that? That's so cool, man. You can see all the little contents, all little. So what we're looking at is this plate of this slime mold, Physarum polycephalum, and this is actually now two specimens, this one and this one, because these three fused, but it started out as these three specimens that had taken up different colors of dye. They're usually yellow, much like this one. But unfortunately, this is that plate a few hours later. This is not exactly the specimen we were looking at because, oh, but I have a picture of that one. Here is the exact specimen we were looking at just moments before taking that video. And here is the tiny little section that we see under the microscope. Isn't that cool? Unfortunately, I didn't have a full plate picture at this moment, but it was the plate that we saw in the other picture just a few hours later. Okay, so this organism is pretty much all I talk about, but this is all one single cell, and it has its own circulatory system. What we're seeing in this video is the circulatory system of this one single cell, and it can't be circular, which is funny. Like our circulatory system goes in big loops. This can't do that because it has to have these edges, it has to have directionality, and so it has to have this end here and then the opposite end here, or here and here. This is actually, I'll get into the name in just a second, but it has to have this flow back and forth because the liquid has to go from one end to the other and back to facilitate respiration like we have with our circulatory system. So this may deserve a new name actually. But so this slime mold specifically is called Physarum polycephalum, and we can dissect its name, and we have seen every attribute that it is named after in just this couple of clips and pictures. So I'll break it down for you. Physarum is it's a play on Greek words, physa, meaning bellows, and arion is a diminutive, so it just means small. So Physarum effectively means tiny bellows, which is adorable. And the reason for this is, of course, this is the reason for that. It's pumping back and forth, and what this looks like on a whole specimen scale is you have at least two ends, usually it's more, at least two ends where the intracellular fluid is being pumped back and forth. But as this one is inhaling, if you will, the other end, or possibly other ends, are exhaling. They're shrinking, they're pushing the fluid out. So this one's pulling fluid in, this end's pushing fluid out, and it starts to look a little like a bellows. Isn't that fascinating? So the tiny bellows, Physarum, the tiny bellows, this microscopic bellowing motion. Okay, now the species name, polycephalum, poly meaning many, cephalum, like cephalo, meaning head, and that is because of two different things, actually. The whole cell, this cell, for example, has probably on the order of tens of thousands, if not hundreds of thousands of nuclei. And nuclei are, of course, kind of considered the brain of the cell. It stores information, it kind of dictates a lot of the activities of a cell. So in that way, it's many-headed because it has many, many nuclei. But in this other way, it also has these multiple ends of the cell, and this is, of course, connected to the bellows that we just talked about. This end and probably this end over here, this over here, and some of this over here. You can kind of break it down specimen by specimen. Of course, this would not, you'd have to look at every individual specimen to determine how many heads it has, but the fluid is going to be pumped and shared between these 3 or 4 sections, and that's where it'll be going to and coming from. So in that way also it is many-headed polycephalum. So Physarum polycephalum, the many-headed tiny bellows.